So, all right, guys. So we are now trying to find the
Sir,
LCM
from 1 to how much did you say?
from 1 to 20.
From 1 to 10, so that is 2, 3, 5, 7, 11, 13, 17, and 19.
Correct. Is everybody in agreement with Miss Scott? Raise your hand for me. Now, earlier on, Miss Wasom would have said 1. Can 1 be a prime number, Miss Wasom?
No, sir.
All right, so why is 1 not a prime? Can anybody tell me why 1 is not a prime number? Miss Cummings, why is 1 not a prime number? Miss Cummings, are you there?
Yes, sir.
All right, so why do you think 1 is not a prime number?
Sir, because 1 can be divided into any number.
Anybody else would like to try? How about you, Mr. Ojeno? Ojeno, can you give us a reason why you think 1 cannot be a prime number?
Not really, no, sir.
Okay. Miss Wilson, you want to try again?
Yes, sir. Is it because it can only be divided by itself alone and no other number?
Exactly. Because based on the definition of a prime number, we see a prime number is a number that can only be divided by itself and 1. But when you think about 1, 1 can only be divided by itself. So it wouldn't fit the definition of what a prime number is. So 1 is not a prime number. Is that clear, students? Let me see the hands of those who understand what I'm saying.
Can you repeat, sir?
So I was saying that 1 is not a prime number based on the definition of a prime number. A prime number is a number that has only 1 on itself. Or in other words, it can only be divided by 1 on itself without a remainder. Right? That's the definition for a prime number. But when you think about the number 1, does it fit the definition of a prime number? Can one only divide it by 1 on itself? You see the contradiction there? Because if we're saying a prime number is a number that can only be divided by 1 on itself, then if we say 1 can only be divided by 1 on itself, it's like we're making a redundant statement, because 1 is itself. You follow it? You follow what I'm saying? So for
Yes, sir.
For that reason, it does not fit into the definition. So we don't call 1 a prime number. So the smallest prime number would be what? The screen, what is the smallest prime number? Are you there, Miss Green? Miss Green? Yes?
Yes, sir.
What's the smallest prime number? Did you say 3? Was that what you said, Miss Green? 3?
Yes.
Is there anybody else who is in agreement with Miss Green? Let me see your hands. Anyone? All right, let me see who's in the chat. All right, that would be Miss Scott. Anybody else agree with Miss Green and Miss Scott? Miss Waysome, are you in agreement with Miss Green and Miss Scott?
No, sir. 2 would have been the smallest prime number.
Okay. Anybody else in agreement with Miss Waysome or Miss Green? Mr. Ojena, whose side are you on? Would 2 fit into the definition of a prime number, Mr. Ojena?
Yes, sir.
Right, because 2 can only be divided by 1 and itself without a remainder. All right, so 2 is a prime number and it is the smallest prime number. All right, so what we're going to do with this table here, we call it a table of prime because in the left column, we're going to keep using prime numbers to divide what we have in the right column. So we are starting off with the smallest prime number, which is 2. Now what we're going to do is to take the 2 to divide any of the numbers that can be completely divided by 2 in the right column. The ones that are not able to completely divide by 2 without a remainder, we're just going to bring them down into another row. Is that clear, guys? So the first thing we want to say is 2 into 8, or 8 divided by 2 give you how much? Come, guys.
4, sir.
So 2 into 8 gives you 4. So we just put down the 4 below where we're starting another row. All right, let me just draw another row. All right, so can 2 go into 3, guys, without a remainder?
No, sir.
All right, so if we cannot get 2 into 3 without a remainder, it means what we need to do is to just bring back down the 3. So we bring back down the 3 and then try to divide 5 now by 2 without a. Can we divide 5 by 2 without
Yes.
a? So we have to bring down back there.
No, sir.
5. Is that clear to everybody what we're doing? All right, now,
Yes, sir.
so we have the next row now. We need to put another prime number in the left column. But what we're going to do first, we are going to check these numbers in the second row to see if any of those can be divided by 2. And if we have any in the second row that can be divided by 2, it means that we have to use 2 again in the left column. Is that clear? Can any of these numbers be divided by 2?
Yes, sir. Before.
Okay, so it means that we are going to use 2 in the column, the left column, in that row. All right? And we're going to do the same thing as before. So we're going to say 2 into 4 gives you how much?
2.
So we write down that 2. And next we are going to say 2 into 3. Can we divide 3 by 2 exactly?
No, sir.
No, so we are going to just bring back down the 3. Next, we look at 5 and we say 2 into 5. Can we divide 5 exactly by 2?
No, sir.
No, so we bring down the 5. Now we have a third row, and can we still use 2 for the third row?
No, yes, sir.
Right. Once there's a number in that row that can be divided by 2, we're still going to continue to use 2. So we use 2 again. So 2 into itself, 2 into 2 give you what? 1. Can 2 go into 3 without a remainder? No. So we bring it back down. Can 2 go into 5 without a remainder? No. Bring back down the 5. Now looking at this row now, can 2 go into any of these numbers in this last row without a remainder?
No, sir.
No. So since we cannot use 2 to divide any of these, that means we need to go to the next prime number, which is what?
3.
So the next prime number is 3. So for that row, in the left column, we're going to use 3. So here we would put 3 in the left column. Everybody is good so far? Everybody following me so far? Let me see your hand. Okay. Now, for the rest of you guys, I need to get your response because I need to know whether or not you're understanding what I'm saying. So if you don't raise your hand, I'm going to take it that you don't understand. So I will base a judgment on that. All right, so we're going to use the 3 now, just the same way as we would have used the 2 in the first 3 rows. Now we're going to use the 3 in this last row. So we say 3 into 1. Can 3 go into 1 without a remainder?
No, sir.
So we bring down the 1. Can 3 go into itself?
Yes, sir. 1
Right.
time.
How many times? 1 time. So we bring down 1. Can 3 go into 5 without a remainder?
No, sir.
So we just bring back down the 5. Are you following so far? Everyone? Give me a raise of hand if you're following so far, or a thumbs up. All right. Now, who can tell me what we're going to do next now? Can anybody guess what we're going to do next? Anybody?
Use the next prime number, sir.
We're going to use the next prime number, which is what?
5.
We're going to be now using 5.
5.
So we're going to put 5 in this left column. And then now we're going to say 5 into 1. Can 5 go into 1 without a remainder?
No, sir.
We put back down 1. And then now we say 5 into 1 again. Can't. So we put back down the 1. So we put back 1 here. Can 5 go into itself without a remainder? How many times 5 go into 5?
1 time, sir.
1. Now, as soon as you get the last row with all 1s, it means that the table, you're finished using the prime numbers. So the table is now, the table would have ended now, so you don't go any further with the table. Now, from the table, how can we find the LCM? Well, we are going to now use the prime numbers from the left column. So all the prime numbers from the left column, we're going to multiply these numbers together, and whatever you get will give you your LCM. So we're going to be multiplying. So the LCM then The LCM would be equal to
120.
2 times 2 times 2 times 3 times 5. And then if we multiply all of those together, what would we get? Anybody?
120, sir.
We would get 120.
120.
Right. Now, so you would just multiply in the easiest way. Right? Remember that rule of the commutative law? You can also use that to reorder or organize the numbers in such a way that makes it easy to multiply. Miss Wilson, you can lower your hand, please. So the LCM is 120. Now that we know the LCM is 120, then we can continue to do what we were doing here in terms of adding our fraction. So what we'll do next now, Ms. Wilson, can you continue to walk us through how to add these fractions?
Yes, sir.
Right, so what will we do next?
So we say that, sir, 8 into 120 goes 15 times.
All right, so 8 into 120 goes 15 times.
Yes, sir. So 15 times 1 is 15.
So you multiply the numerator, which is this one, by 15. We get 15, so we put down 15 below. And remember now, when we multiply the numerator, now what we're really doing, we are creating fractions equivalent to the one that we have above, where the denominator with a denominator of 120. That's what we're doing. All right. Next, what would?
So, sir.
Yes, Ms. Green. Go ahead.
Excuse me, sir.
Sir, differently from the table, sir, you have any other way we could do it to get the LCM, sir, without using the table?
Well, there is another way, but it's kind of pretty similar to the table. It wouldn't be much different from what they do in the table, but the table is a very reliable way of getting the LCM. If you are not able to look at the denominators and by inspection, you can use the table. What is it that you don't like about the table, Ms. Green? Is it too long?
Is that yes, sir. I was just wondering if there was any other way.
All right. No, I don't think you will be getting many questions to do where you'll always have to be calling on the table. So I wouldn't worry about it, but at least you know a way how to get the LCM if you're unable to look at them and just by inspection say what it is. Is that clear?
Yes, sir. I will always, when we are doing that, sir, we always use the prime numbers or...
Oh yeah, you always use the prime numbers in the left column. And you start with the smallest ones. And then as soon as you can no longer use those, you go to the next one and so on. All right?
Okay. Yes, sir.
Okay. It's a good practice. It's not so hard. If you're doing it for the first time, it seems a little long, but at the moment you start practicing it, you realize that it's not as bad as it seems. All right, so next what we're doing now, Ms. Waysome.
All right, sir. So we say that 3 into 120
yes.
goes 4 times. So 40 times 2 gives you 80.
All right, so 3 into 120 goes 40.
Mm-hmm.
So we take that 40 now to multiply the numerator. In this case, we are multiplying 40 by 2. We get 80. So we put the 80 down here. Next, we are also going to work on the other fraction. So what next, Miss Rayson?
So we say that 5 into 120 goes 24 times. And then 24 times we give you 72.
All right, so here we would have 72. So 72 here. Now, after we have done that, what is the next step, Miss Wilson?
We'll sum everything. We'll sum everything together, sir, and we'll get 167.
From the numerator, and we get?
We get 167, sir, over 120.
167 over 120.
Yes, sir. Which can be further.
What kind of fraction is this?
Improper fraction, sir.
All right, so we don't want it to be left that way. So what we're going to do?
Yes, sir. So we say that 120 into 167 goes one time and leaving a remainder of 47. So the answer would be 1 whole and 47 over 120.
Okay. All right, so did anybody else try this question and arrive at this answer? Let me see your hand.
Yes, sir.
All right, very good. So that would be the answer to that question. Now, so the rest, so let us now look at one question that has mixed numbers in it. So I'm going to clear what we have here. Can I clear what we have here, students? All right, so I'm going to clear what we have here. Now, I'm still a little bit behind with the videos. I should be posting these videos on the website soon. Just bear with me. I am just trying to get things organized so that I can get these videos on the website so that you can revisit them and watch them over again. All right, so we're going to do question 3. Is there anybody who would like to volunteer to walk me through question 3? So question 3 is 1 3/8.
Can I try, sir?
Sure. 1 3/8 plus 3 9/16. All right, go ahead. Who is that? Who is that? Miss Fabia? Was it you wanted to try, Miss Fabia?
Yes, sir.
All right, go ahead.
Yes,
Tell us
sir.
what to do.
Okay, sir. So I would use 16 for the LCM.
Before we jump to the LCM, remember once you're working with mixed numbers, we can do 1 out of 2 things. Anybody remember how to add mixed numbers?
Yes, sir. We can either convert them to improper fraction, or we could just separate the whole numbers and then work with the single fractions.
Right. Do you remember that, Miss Trivia? Miss Trivia?
Yes, sir.
You remember what Miss Rayson is saying?
I didn't get that, sir.
Based on what we did in the previous class, if we're adding mixed fractions, we need to either first convert our mixed number. So we can convert it to what? Into improper fraction. So before you even start talking about the LCM, you're either going to convert them into improper fraction, or you're going to add the whole number parts separately, and then you add the fractional part separately. So I would like to know, which way are you going to take? Yeah. Not sure?
I did not add the whole numbers first. What I did was to use the 16 as the LCM, and I would divide the 8 into 16, which would go 2 times plus the numerator, which would be 3. That's how I work mine.
All right. Walk me through what you're doing, and then if anything, I'll try to clarify where you're going wrong.
Okay, sir. So I
think you should be able to write if you want to do it. Are you able to write?
Pardon, sir?
Can you write from your end?
Okay, yes. Yes, sir.
All right, so go ahead and do what you are doing.
1 and 3.
If you're unable to write, I'll do the writing for you.
Okay, you can go ahead.
All right, so tell me what to do then, and I will do that.
All right, just rewrite the question over the other side.
This question, have you seen
number 3?
Yeah, we have 1.
Oh, you have it already?
Right. So next, what do we do?
It'd be 9/16, sir.
Oh, 9/16. All right, continue now, Ms. Trivia.
Hold on, what's wrong?
You just tell me what to do. You don't have to write anything.
Okay, sir. I use 16 for the LCM.
All right. So what you do? You draw a line below and put the LCM on 16. That's what you're saying?
Yes, sir.
Okay. Let us see where this is going. Continue.
Then I said 8 into 16 goes 2 times.
8 into 16 goes 2 times.
Yeah.
What?
Hold on, sir. Hold on. Let me see what I did wrong. Hold on. One, two, three. Oh, sir, let me tell you what I did. That's wrong. Let me tell you how I did mine. I said 1 times 8. I was doing it the short way. 1 times 8 would be 8 plus the 3 at the top would give me 11.
All right. So that's what we call the conversion to improper. So you should be doing that before you actually find the LCM.
Yes, that's what I.
Right. So where you now just jump in to find the LCM, where your numbers are still in mixed fraction, that would not be the first step. All right. So the first step, you can convert your mixed numbers to improper. So let's do the conversion then, Miss. Convert 1 3/8 into improper. What you say?
Sir, Miss Polo got kicked off.
Oh, she got kicked off. Who else would like to continue doing this question until she gets back? Or you want us to give her a little bit of time to see whether or not she'll get back on? And you may be kicked off in another 2 minutes, so you'll have to log back in. All right, guys? All right, she's back. Are you back with us now, Ms. Trivia? Ms. Trivia, are you back? Can you hear me, Ms. Trivia?
Yes, sir, I'm back now.
Okay, good. All right, so let us continue what you were doing. So let us first convert these convert these mixed numbers into improper fractions. So the first one, 1 and 3 over 8 would become what? Walk me through the step, Ms. Trivia.
1 times 8 would be 8. Plus the 3 would give us 11.
All right, then what would we have down here now?
11, sir.
What we do with the 11? Just put it down by itself.
Yes, sir.
You sure? Is anybody else in agreement?
Over 16, sir. 11 over 16.
No, it would not be over 16 at all. Because
Hold on, sir. Over 8. Over 8.
8, right? Correct. Because remember, you're
Yes, sir.
converting this to improper. So you wouldn't change the denominator.